Let's understand how can we calculate the total number of optical isomers. Okay, so for the compound which are actually unsymmetrical compound means the compound which have different type of terminals. Actually they have total optical isomers are is equal to 2 raised to power n. What is n here? N is equal to number of chiral center. For example, if this is a compound which have different type of atoms like that, it is unsymmetrical compound. For this type of unsymmetrical compound, if there are two chiral center are there, two chiral center are present in this compound, so one chiral center and second chiral center, so total number of optical isomers will be 2 raised to power n, means 2 raised to power 2 means that is equal to 4. Now let's understand for symmetrical compound the total isomers, optical isomers can be calculated by using the following formula. If total chiral center are n, then if n is even number, we have to use the formula total optically active isomer will be 2 raised to power n minus 1, and there will be meso compound 2 raised to power n by 2 minus 1. Meso compound are those compound which are not optically active. They have plane of symmetry, chiral center, but due to plane of symmetry they are optically inactive compound. Now total optical isomers will be equal to total optically active plus that meso. So 2 raised to power n minus 1 plus 2 raised to power n by 2 minus 1. If total chiral center or total chiral center are n and n is odd number, then we have to use the formula total optically active compound 2 raised to power n minus 1 minus 2 raised to power n minus 1 by 2. So meso will be there 2 raised to power n minus 1 by 2. So total optical will be equal to optically active plus meso 2 raised to power n minus 1. For example, if we solve this question, so in this question we can understand that we have to find out total stereoisomers, enantiomers plus how many stereoisomers, enantiomers plus diastereomers are there is for this molecule. Now the possible symmetry of stereoisomer is a function of absolute configuration, so we have to use the formula that is total optical isomers. Total optical isomers will be 2 raised to power n minus 1 plus 2 raised to power n by 2 minus 1. So what is the value of n here? N is actually 6. 1 2 3 4 5 and 6. So 2 raised to power 6 minus 1 plus 2 raised to power 6 by 2 minus 1. So it is equal to 32. That will be optically active plus 4 meso. So total optically active, we can say total optical isomers will be 32 plus 4, that is equal to 6. So in this way we can find out total optical isomers. Thank you.